This is Color for Digital Design, and I'm Alvalin Lundgren. This is session 5, and we're dealing with color contrasts and color management. So let's first talk about color contrasts. Color contrasts were first proposed by Johannes Itten, who was part of the Bauhaus school. And through observation, he added to our understanding of color theory with the idea and the principles that we see different aspects of color at the same time. So that when we're looking at anything, and all these basically happen concurrently. So the 7 color contrasts that he observed are hue, which is the color property for both additive and subtractive color. And hue deals with the sense of chroma, the idea that something has color. Hue is also a color family. It's the parent of a color family, and it's a spectral level color. Hues are full intensity, fully saturated. Value, it's a property of subtractive color. Its opposite is luminance, which is the additive color property. And that's the understanding or the perception of lightness and darkness in a color. Intensity or saturation is the sense of something being vivid or dull, something being bright or modulated. And intensity and value, very often people have a hard time separating those two properties. We're used to thinking of bright and light are the same thing, or dark and dull are the same thing, but that is not the case. You can have colors that are light and bright and dark and bright. And intensity basically deals with the purity of a color, and that applies to both the additive and the subtractive systems. Color temperature is a visual understanding. There is physical color temperature, which is measured in degrees Kelvin. Physical color temperature is just our sense of warmth or coolness. So orange is warm, blue-green is a cool hue. Extension is the understanding that the size or proportion of the color, shape, or form that we're looking at affects how we see it. So a smaller swatch of color looks very different than a full wall of that same color. And complementary and simultaneous contrasts both deal with the after image on color. After image always happens when we look at something. And it has a different effect on complementary colors than it does on non-complementary colors. So complementary contrast is the after image effect on opposite hues when you're dealing with, say, red and green, or blue and orange, or yellow, orange, and blue, violet. When you have those colors paired, combined together, there's going to be certain things happening within that after image. One of them is that they will intensify visually, and another thing is that they will balance between the 3 primaries. Simultaneous contrast is the same after image effect, but on anything that is not complementary. So if you have red and blue or red and orange, there is a simultaneous contrast effect that happens. When the hues are opposite but not directly complementary, like red and blue or red and blue-green, the after-image effect actually increases the sense of intensity without affecting the physical saturation of the color. And on analogous colors and hues, simultaneous contrast causes those colors to appear more dull, less vibrant than they do in other situations. So simultaneous contrast, the after image, adds some complexity to how we perceive things. And designers and artists use these 7 color contrasts to manipulate space, to create hierarchy, to balance a design or an image. So we're working with these ideas all the time. So let's look at a few examples of these things. First of all, hue contrast. In this photograph, there's not a lot of hue contrast. The greatest amount of contrast we have in terms of the hues is that there is a yellow and yellow-orange going on in the foliage, and green also going on. So we have a combination of red and yellow, and we have a combination of blue and yellow, then there's blue, and most of the other colors are neutral. There's a little bit more red in the road showing up, but the house is gray and white, and there's a little bit of saturation on the door. But this is minimal in hue contrast because there's not a lot of opposition of colors. There are not a lot of opposing hues. This is very different. We have cool hues and warm hues. We have two blues. We've got more of a cyan, and it's lighter in value. This is darker, more saturated, a little cooler in temperature. Then we have a red, and we have a fairly warm yellow, and we also have, of course, some black and white, which are not hues. There's a lot of energy in this image simply because of the types of color and also how the color is distributed through the image. So there's a lot of contrast here in terms of hue. There's very little contrast here. And then we have value contrast. Value, of course, is light and dark differences. Value contrast allows us to see the lettering and the lettering down here, and also helps emphasize the coffee cup. And then we have the dark figure, and then we have a mid-value orange that is slightly desaturated at the same time. This has a very similar color scheme, but the value contrast is limited. Here we have light and light against dark and mid-value, so there's a full range of value contrast in this image. There is a reduced range of value contrast here. We have lighter value in the yellow, but both the orange, the black, and the yellow here are close together in value. So the value contrast in this illustration compared to this one is very different. And that value contrast difference creates a different understanding of how legible things are, but also it creates a different mood in each image. Intensity contrast is very often used to create a sense of depth within a two-dimensional image. So things that are more intense or more saturated are going to come forward, where things that are less saturated or neutralized will sit in the background. So we get a greater sense of depth in this image because the red at full saturation comes forward. Another thing that's working here is value contrast. The white of the lettering comes forward against the darker background. The white of the lettering comes forward against the darker red. So there's a variety of layers of color contrast going on in this design. Extension contrast deals with proportion of a color. In this painting, the red is dominating everything in terms of its amount, the extent of it, compared to the blue. So the red is kind of the bully in a way, but it creates a certain kind of mood and visual impression. And then we start noticing the blue and the yellow. So what's happening here is that the overextended or greater proportion of red is having the most impact on us visually, and it's affecting how the other colors appear as well. We also have value contrast going on, definitely hue contrast. We've got red and blue and yellow. So we can see that other color contrasts are still happening, even though this is very obviously an extension contrast thing. Temperature contrast, warm-cool colors, is also used to create a sense of space or a perception of space in two dimensions. So on this book cover, we have the yellow lettering and the banner coming forward. The orange comes forward as well. The blue sits back in space. So what happens with temperature contrast is that warm hues are naturally advanced. They're more dynamic, they're more assertive. We tend to see them first. Cooler hues like blues and greens sit mid-ground or background naturally. And it doesn't matter the shapes that they're on. It doesn't matter if they're on typography or on shapes or on forms or they're the background space. The color has a dynamic quality on its own that is independent of how that color is applied. So we can apply the temperature contrast along with other contrasts to help us manipulate spatial depth in an image. Also here we have hue contrast because we've got blue and orange, so that those are complements, and then we also have yellow. So there's a wide range of hue contrast. We have value contrast. The yellow areas, the title and so forth, are coming forward visually because they are lighter than the background. The author's name is coming forward against the lighter yellow background because it's darker, so it's contrasting in terms of value. And there's a greater amount or proportion of blue than the warmer colors in this design. So we can see again that various color contrasts work at the same time and coordinate with each other. Complementary contrast is the contrast that happens between direct opposites. So it only occurs with complementary colors. So this is an older ad for Dodge, and it's a very effective ad just by virtue of using complementary contrast, restate visually the tagline that Dodge is different, and it's specifically talking about its trucks. So it's using red against green. This also uses extension contrast. The green is the greater extent, the red is the smaller extent. So the smaller proportion of red creates a strong focal point and emphasis, and then situated very close to the logo, we get the immediate association of the red and the logo, and no words are needed. There's no headline needed. The color creates the headline. The color creates the concept of the ad. Simultaneous contrast happens whenever colors are not complementary. So in this image, which is highly complex, containing both illustration and typography, the contrasts are myriad. There's a lot of color relationships going on, and therefore a lot of simultaneous contrast. The red against the yellow against the green, those are not complementary. The red against the blue are not complementary. The red and the yellow will kind of dull each other out because the red's got some yellow in it right here. The yellow and the green definitely are both working to de-intensify each other, and they appear duller than they would normally. There's also value contrast and lack of it, so the H is very light against the background here, but the T is a lot darker. The R is hard to see, but the F pops, and that's a value contrast thing. There's also a lot of warm-cool. There's temperature contrasts going on in this, and it makes for an overall very energetic, very lively design that's interesting to look at. So again, there are 7 color contrasts, and they happen every time we look at something, and they happen all at the same time, with the exception of simultaneous contrast does not happen with complementary color, and complementary contrast does not happen unless you have complementary colors working together. So designers and artists and photographers use color in particular ways. There's basically 3 understandings or 3 different ways that we use color in our work. Color choices are never arbitrary. There should always be a purpose to the color that we use. So one of the ways we use color is what's called optical color, and that means that color is representational or realistic. If you have grass in an image and the grass is green, that would be realistic or representational color. So optical color is using color in the normal conventional manner to represent things. And we use optical color for greater understanding or to help make connections and give people an understanding what they're seeing. Heightened color is based on representational or optical color, but it's simplified, or the vibrancy is boosted, or it's flat color. It's amped up or modulated down in some way. An arbitrary color is using color for aesthetic purposes or for how color functions. Just for an immediate example, the black type on the white background in this slide is an arbitrary use of color. It's utilitarian for the purpose of legibility and clarity. So looking at the same image with the color uses applied, just for example, this is as shot, straight out of the camera, no editing of any kind. Heightened color, the vibrancy has been amped up a bit. So we still see a blue sky, and we see kind of the natural color of the rock and the dusty green of the foliage right in here. But this is not what we actually see. This is not the way it actually is out there in Joshua Tree. So the colors here have been heightened, exaggerated, and amped up a little bit. They could also go the other direction. Then arbitrary color is using color for visual effect or for the purposes of utility. And here we have a duotone. We still have the image, obviously, because of value contrast, but the color is now arbitrarily assigned because it's not trying to directly represent the original or the way things actually are. We can see heightened color use in this illustration. Obviously, the birds are drawn in a very stylized, abstracted manner, and the color palettes recall the original color of the plumage on the birds, but they are not directly representational. This is optical color. This is a portrait that's using color to depict a person as he actually was, and the effects of the lighting on the skin tones. There might be just a small amount of exaggeration in how the color is used, but it's still within the optical or representational mode. This landing page uses a combination of color applications. Obviously, she is in a representational or optical mode. Then the background color, the black bar, the bottom red-violet, the orange, the opt-in box, the typography, those are all arbitrary uses of color, and they're arbitrary for effect, to capture attention, or for utility. So you can combine these color uses as needed. This is a really good example of absolutely arbitrary color for visual effect. So in the previous session, we started talking about calibration, which is the starting point for color management. And the idea of color management is to control color from input all the way through to output so that color stays what it is. Because of the various devices and various color spaces, there's a lot of shifting that can go on. And what you see on your computer screen does not necessarily equate to what you see in a printed output, and it doesn't equate even to what you see between browsers or what you see in Photoshop versus deploying something on social media. And so color management comes into play when color has to be accurate within various media. There are devices that we use to capture color, such as cameras and scanners. There are devices that we use to create and display color, such as computers, tablets, phones, and projectors. There is software, including operating systems, apps and applications, browsers, and all of these have to work together. They don't naturally work together. So color can go any which way when we're working with it, depending upon how we're using it, what software we're using, whether things are printed or whether they are digital. There's just a whole bunch of graphic environments that create color chaos. So our job as designers, as illustrators, photographers, is to manage color to the best of our ability so that it remains true from start to finish. Different cameras, different machines will capture color in different ways. I've mentioned previously that Nikon's and Canon cameras have different color reads and different color settings, different ways of defining color. That means that the same image appears differently on different displays and devices. And devices don't naturally match each other. Another thing to consider is that displays are additive color. They are backlit. They are a source of light. They are originators of light, whereas print is reflective and it's subtractive. Two different color spaces have to work together. So we've got additive spaces having to work together, and we have additive and subtractive space having to work together. Printers don't all interpret color the same way, and printers, being subtractive, have a much smaller color space than your computer display. The amount of color that's in a print is a lot less than the amount of color that you can see on your screen. And then if you're printing offset or you're printing stochastically via your inkjet, you're going to get different results with the same file. We need to define an image in the right way, which is characterizing it in terms of its color understanding. We need to standardize how the image will be interpreted on various devices. And then we need to be able to translate the image, the information within the image, so that it is deployed properly between print and digital environments. So let's look at some definitions and start moving forward with how we manage color. So a color space is a color model or a color system. Color spaces are three-dimensional. We are used to working with color in a linear understanding, which would be a color spectrum. This is the way color actually exists. But at the same time, it's also volumetric. And when it comes to digital color, the three-dimensional space understanding is crucial for being able to pinpoint and select color and to manage color throughout the entire design and production process. In traditional color theory, we work with color as a two-dimensional understanding. We place it on a circle, which is a two-dimensional understanding of the sphere. So we're already used to working with color as a spatial concept. So expand the hue circle into a sphere, and this is the idea of what we work with digitally. So a color space is a nonlinear expression of a color system, and it is three-dimensional. And there's a variety of color spaces that we work with for various purposes. Another definition is gamut, which is not the same thing as gamma. Gamut is the full range of possibility or capability of any device to create or to reproduce color. So printers have a gamut, your smartphone has a gamut, your computer display has a gamut, your television screen has a gamut. The human visual gamut is much larger than what computers can create and display. And what computers can create and display in RGB and the additive system is a lot larger than subtractive color, which is printed output or paints and other types of pigments. So the same color will look differently in different color spaces. Every color space has its own gamut. Common color spaces we've already talked about are things like CMYK or RGB. Grayscale uses single color but ranges of value. So color management, we have to have an understanding of what a color profile is. Profile is not the same thing as a space. A color profile is criteria or information that we use to translate an image between color spaces. So the idea is you have to set the right profile with the image for how it's going to be deployed. So you'd have the same image going to print as being deployed on your website. You're going to use different color spaces for each of those uses. We mentioned briefly in the previous session in regard to setting your white point and calibrating your display, but gamma is the overall range of luminance that a device is capable of. There are system level ranges, and there's also file level ranges. So you can look at a photograph that has low value contrast, and it would have a lower gamma than something that has a wider value contrast. When you calibrate your computer display, you are calibrating on a system level. That system level gamma is going to affect the appearance of the gamma in each individual image file. And by image file, I'm not just talking about photographs, I'm talking about anything that you're viewing on screen, including InDesign layouts and PDFs and PowerPoint presentations. So color management is simply the process of controlling color from device to device and environment to environment. The idea is that we want to have accurate and consistent color understanding within an image from start to finish. And color management begins with calibration. So the first thing you need to do is calibrate your display and your printer, your computer and your printers, in order to bring them into closer alignment. If you don't calibrate your own display, you're not going to be able to manage anything well. That's your starting point. When you calibrate, you are setting up color profiles. There are color profiles that are specific to a device. The color profiles can be in additive or subtractive color. So I've mentioned previously that my Canon printer, which would be subtractive color, deals with color differently than my Epson printer, which is also subtractive color. So they're both in the same color space, but they don't use the same color profiles. To calibrate the printer to my display, I have to set up different color profiles for each of those output devices. Then there are independent profiles, which are more application level, and they are used by color management modules. Examples of those independent profiles are the CIE, sRGB, and ICC, and we'll talk about those a little later on. The top level color spaces are RGB and CMY. Within each of those systems, there are subsystems. There are more subsystems in the RGB additive color system than there are in the CMYK color system, which is the subtractive system. RGB is the basic default working space of Photoshop. It is device dependent to your computer and to the software. RGB, of course, is the additive system, and for all digital work, anytime you are working digitally, you are working in the RGB system. If you switch to CMYK color mode in Photoshop, or when you're working in InDesign, which is default CMYK color mode, it's a simulation because the subtractive system exists in print, not digitally. But RGB is the standard for all working files, and it is a three-dimensional color space based off of red, green, and blue. Various combinations of those three primaries will give you colors at various positions within a three-dimensional volume, and that's what's being illustrated here. This dimension, and this dimension, those are your three criteria. So there's a red dimension, a green dimension, and a blue dimension. And you can pinpoint any specific color anywhere within that volume. Now, sRGB, standard RGB, is also for digital work, but it's not for your working files. You convert to sRGB whenever you want to deploy an image onto the internet. sRGB is a smaller color space than RGB, but it allows more consistency when you're viewing an image on the internet. So any image that you deploy to your website should be in sRGB so that not only are you seeing it as accurately as possible, but everybody else who's viewing it from their particular computers and through their particular browsers are seeing it as accurately as well. You don't want to use sRGB for anything that's not deployed on the web. You don't want to use sRGB, say, for a projected slide deck presentation. You want to use RGB. Adobe RGB is larger than sRGB in terms of the amount of colors. It's a larger color space, has a larger gamut, but it has a smaller gamut than regular RGB. It's a color space that was developed by Adobe specifically for digital photography. And if you are running G-Clay prints or indigo prints, things like that, you would want to set your color space to Adobe RGB. So how do you set color spaces? The most basic way is to, when you open an image, you go to Image and you go to Mode, and then within Mode you have all your options. You've got RGB, CMYK, or Lab, or Grayscale. Those are the most common. Now, if you want to change an image to a different color profile that's not within the mode, you have to go into the Edit menu in Photoshop and then find Color Settings. And then within those color settings will be all the profiles, the ones that you have created, the ones that your printer has added. You can see my Epson here has a bunch of color profiles, and my Canon has a bunch of color profiles. You can also see that there are a variety of profiles here. So all of these are the different profiles that are currently within the system that can be invoked at a moment's notice. This is accomplished through color settings, not through the image menu in Photoshop. The CMYK color space, of course, is subtractive, deals with pigments, inks, paints. It's used for anything that's printed or painted. It measures color by three aspects: the amount of magenta, the amount of yellow, and the amount of cyan. With spectral, you measure wavelength frequencies. This is the higher end, more exact means of controlling color, because you need to use various measuring devices such as the spectrophotometer. Another color space is HSB or HLS. They are interchangeable. These deal with the three properties of additive color. So again, this is a digital or additive color space. So it's hue, luminance, and saturation, or hue, saturation, brightness. These are interchangeable. The hue, luminance, saturation, those are the three additive color properties. So color is measured on those three coordinates. So again, we're looking at a volume, and we're looking at an understanding of hue around, say, a perimeter or a circumference, and luminance levels going up and down. So there is a dimensional understanding, and color is mapped on the basis of how much luminance it has, what its hue family is, and whether it is fully saturated or a modulated color. And so the idea is that hue revolves around its concentric, luminance is a vertical understanding, and then saturation, the more saturated colors are radiating out from the center. The center is desaturated or neutrals. The perimeter is fully saturated color. So you can see that if you take a hue circle, standard 12 hue circle, with the idea that to get neutrals you start mixing across the hue circle, and to get the true neutral you mix the three primaries together or complements together to get the true neutral. It's kind of the same expression, it's just a different way of presenting the idea. C-Lab is a very similar idea, but it uses a compass or a polar coordinate between green and red and blue and yellow. And you can see we still have the full spectrum of color, and this can be translated into the 12 hue system. It has the same idea of the color sphere having a core that's white and black, and then all the grays in between from white and black going down the core from pole to pole. The more saturated color are again toward the outer circumference, toward the perimeter, and the less saturated will be moving toward the center. So again, it is a three-dimensional spherical color space, and you designate color in terms of the amount of whiteness or blackness that can translate into the luminance or lack of value, and this would be full value and lack of luminance, what the hue is, and you just plot color anywhere along either coordinates, these perpendicular coordinates, the amount of yellow versus the amount of blue, the amount of green versus the amount of red. So whenever you see lab color, that's what's going on. Color mapping is the process of defining a particular color based on coordinates within a color space. So this would be an example of a CMYK color space. We've got black and we've got white, and these are opposite corners within a six-sided cube. And so we have three dimensions, this dimension, this dimension, and this dimension. And I could map a color along this line and then going back into space and maybe up one. And then I could designate or define that particular color and notate it. So the idea of color mapping is locating a specific color within a color space. In the previous session, I talked about color pickers, and you had palettes and maps. The color maps in Photoshop are a two-dimensional slice out of a three-dimensional color space. Since we work with color, and because we manufacture things and create things, color standards have been determined and put into play for various industries to follow. Back in 1931, the International Commission on Illumination, or the CIE, determined that C-Lab, that color space, that way, that color profiling would be the standard way of defining color space when it comes to lighting for homes and industry. It is how luminance levels and chroma levels in various types of lighting are determined. So we have an understanding of, okay, you've got a 40-watt light bulb versus a 100-watt light bulb, and they have certain ideas of luminance and certain color outputs. You have task lighting versus ambient lighting, so task lighting has to be a certain luminance level. And so these are the kinds of color standards that the CIE deals with. The ICC was established in '93 to set color standards across all digital platforms. So individual softwares, computer display, internet browsers, colors all standardized through the ICC. And so when you set a color profile for an image, or you are coordinating between, say, Photoshop and Corel, those softwares are now using those same color standards, those same ICC definitions for color. Prior to the ICC, let's see, back then it was PageMaker and I think Quark. Quark was the big one for page layout. And then you had things like Illustrator and Freehand. Well, the same color defined in Illustrator would appear differently and be defined differently if you opened up that file in Freehand. And if you brought in an Illustrator EPS file into Quark, the colors in the EPS file would also come into Quark, and Quark would have its own colors, so you'd have two of the same color but defined differently. Then you had to kind of color manage within the software itself, within the Quark file itself, to actually get rid of some of those colors, because if you sent it to print, it would be confusing in the prepress process and it wouldn't print accurately in process printing. So what we do with color management is to strive to get an image to appear the same, whether it's displayed or printed, if it's captured in the camera or displayed digitally. So we try to match color from point A to point B to point C. Your working color space is not necessarily going to be the final color space or the final color profile for the image. Depending upon how an image is going to be used, you will have various versions of that image with different color profiles assigned. So you might have the same image with an sRGB profile assigned, or you might have it with a CMYK. Especially with branding, when you have brand colors, you want to coordinate and manage and control colors so that it matches as best as possible between various print outputs and various digital uses. So you will create different digital files or digital images, each with its own color profile, and those profiles will be appropriate for how the image will be used.